Alright, so we'll be starting our example 3, which it's similar to the last one, but I don't think that last one was hard enough, you guys. What do you guys think? The harder the problem, the more exciting the problem. So we're about to have a ton of fun, so get pumped up. So we are still evaluating piecewise functions. Alright, and we are evaluating at 2 different values just like we did in the previous problem. But if you see, we now have variables in our function notation. So we're going to have to do a little bit more work to find our final answer. Alright, so before we dive into that, I'm just going to go over inequality notation and interval notation one more time to make sure we got it. So, for our first one, this says that x is all the values that are less than or equal to 2. So if you look at our interval notation, remember we always put the smallest number on the left-hand side and our largest number on the right-hand side. So if we are everything that is 2 and smaller 2, that means we're headed in the negative infinity direction. We're headed where all the values on the x-axis are going negative. So we are headed off to negative infinity, which you guys better watch out. That's where the demon cats hang out, so you better watch yourself. Alright guys, and since that is our smallest number, we put it on the left-hand side. And since we can't really ever equal infinity, we're going to put a parenthesis, not a bracket. And then since this is everything that's 2 and smaller than 2, the largest number we have is a 2. So I'm going to put that on the right hand side, and since it can equal 2, since we have the line underneath our inequality, we're going to put a bracket. Alright, same thing for this. So this is all the values for this part of our function are where x can be larger than 2, not equal to 2, so be careful. So since these are all the values larger than 2, now our smallest value is going to be 2. So we throw that bad boy on the left-hand side. And since it cannot equal to 2, we put a parenthesis. Now, since we're at the values that are larger than a 2, we are headed in the positive x direction. So in the positive values. So we are headed in the positive infinity direction. So to infinity and beyond with Buzz Lightyear. It's going to be a blast, you guys. So that's our largest number. And since we cannot equal infinity, we put a parenthesis. Alright, so now we're going to actually dive into our problem. So we are evaluating the piecewise function at the values where x is -1, which I made that the first problem in part A, and where x is equal to 4, which I made that the second problem in our part A of example 3. Alright, so first thing we have to do, we have to figure out which one of these inequalities will allow a -1. One of them loves -1s, the other one does not. So we have to figure out which one the -1 belongs in. So if we look at our inequalities, we put -1 in this first spot. -1 is definitely not larger than 2. So the second function rejects the -1. So it is not allowed in our purple equation. But if you look in the orange equation, if I put a -1 in for x, -1 is definitely less than or equal to 2. Awesome, you guys. So that means the one that will work for when x is -1, the one we'll be using is the orange equation, which is super exciting. So we are only going to focus on this first equation because that is the only one where our -1 is allowed in. So you always look over here first and then you look over here. So we're going to be focusing on this 2x plus 1 right now. And this is the function value where the x is -1. So let's solve for f of -1. Alright, so our f of x is 2x plus 1. So remember, when we do our function notation, we replace all of our x's with the -1. So I'm going to start with my 2. But right beside my 2, there's an x. So that means that x is going to transform into a -1. It's a super awesome transformer. So my x right here is now going to become a -1. And I'm just going to bring down my plus 1 because that does not have an x. So now we are just solving for x using our function notation. Alright guys, let's get going. So let's start here. Our 2 times a -1 is a -2. Then I'm just going to bring down the plus 1. Alright, and then -2 plus 1 will give me a -1. Bam! That one is donezo. That was fun times, you guys. Now let's look at this number 2. So our number 2 now, we have to figure out which function will 4 be allowed in. One of them allows 4s and one of them rejects the 4s. So we have to figure out which one gladly will accept a 4. So if we look in our first inequality, remember you look at the inequality first, then you look over here. So if I put 4 in for x, 4 is definitely not less than or equal to 2. So that one fails. Super fails. Nope. Not allowed. Alright, but if you look at the second one, if I put a 4 in for this x, 4 is definitely greater than 2. Yay! So the purple one works. So in this one, we're only going to be focusing on our purple equation. Alright guys, let's dive in. So we will be solving for the function value when x is 4. Alright, which? Let's dive in. So we want to solve for when f is 4. So if we look here, my x is going to change into a 4. So we have a 4, or we have an x squared. So I'm going to put my 4 in a parenthesis with the squared. And technically, you guys, I just realized, my bad. Technically, our function is an h, not an f. So I get used to solving with the f, but you can really use any letter for our function. So technically, I apologize, all these should be h's. Silly Miss Long. Sorry, guys. So let's just change all these to an h's real quickly. So it means the same thing as f. You can use whatever variable you want for our function. So this first one, these should all be h's instead of f's. My bad, you guys. Alright, this one should be an h as well. I'm sorry. Get mad at me, I'm sorry. Whiteout is your friend when you use pen in math. Alright, so if you didn't change it to that, it's not a big deal. Just whatever this is up here should technically be the same letter as down here. But none of us are perfect. We all make mistakes. Alright, so over here, technically this should be an h as well, since my function is an h. But again, I won't be overly picky. If you accidentally do this on a test, I'm not going to count off. It's not a super big deal. Okay, so let's keep on going. So, anyways, we will now be solving for when the function value is 4, which our function is an h, not an f. So we need to try to make sure those are the same. Okay, so let's solve for when h is 4, which, remember you guys, that is referring to our second function. So I'm going to put my 4 in a parenthesis with the squared because we see an x right here. Our x is going to transform into a 4. So we're going to have 4 squared, and then minus the 4. Alright, we have to do our exponent first. So 4 to the second power will give me a 16. And I'm going to bring down the minus 4. And then 16 minus 4 will give me a 12. Bam! That one's done. Alright, so my final answer will be h of 4 equals 12. Ta-da! Again, I apologize for the wrong letter. I apologize.